This is an AQA GCSE chemistry question. It's Trilogy 2019 and it is a foundation question. So, gonna take a look at the question first for you to have a go and then we'll review. Starting off with part A, part B, part C, part D, and finally part E, a 13-mark question in total. So starting off with the review, part A, this is a straightforward definition question. You need to learn the keywords and their definitions, and water that is safe to drink is potable. In terms of describing a test for pure water, one of the key ways to test for purity of anything is to measure its boiling point. And that's what we're going to do here. We know the boiling point of pure water is 100 degrees Celsius. We know that if we add impurities, it will change that. So we boil it and we measure the temperature at which it is boiling. If it's 100 degrees C, it tells us the water is pure. Part C follows the marking structure of a 6 marker, even though it's only 4 marks. So a method to determine the mass of dissolved solids in a 100 cm cubed sample of river water. You can see the levels here. You will design a plan that would lead to a valid outcome, identifying all key steps. And to get a level 1, you've got some of the key ideas, but it may not follow a logical structure and it may not lead to valid results. In terms of the indicative content, what we would do is weigh the container, the evaporating basin potentially, and make a note of that mass. We then add 100 cm cubed of the river water to it. And then we evaporate. We're going to heat it, and we're going to heat it until it's dry. Now, heating to dryness is a very important chemical or skill within chemistry. You heat, and then you measure the mass, and then you heat again, and you measure the mass, and you continue doing that until the mass stops going down. It's at that point you can be confident that every part of the water has evaporated. We're then left with the container and the solids that remain. So we can take the mass of that, and the difference between the container on its own and the container with the remaining solids is the amount of remaining solids. So that's what we're aiming for. For part D, a sample of river water contains 125 milligrams per decimeter cubed of dissolved solids. What would the mass be in 250 centimeter cubed in grams? And the answer must be to two significant figures. Well, 125 milligrams is 0.125 grams, simply divided by 1,000. And 250 centimetre cubed is 0.25 decimeters cubed. Now, we actually had 125 milligrams per decimeter cubed. So it's actually 0.125 grams per decimeter cubed. So what we now have is a volume and we have a concentration in grams per decimeter cubed. So if I multiply those two together, I will get the mass. And the mass comes to 0.031 grams. And you'll notice that that is the two significant figures as requested. And we move on to part E. A water company allows a maximum of 500 milligrams per decimeter cubed of sulfate ions in drinking water. A sample of drinking water contains 44 milligrams per decimeter cubed. Calculate the percentage of the maximum allowed mass. Well, you have 44 and you're allowed 500. So we work out what 44 is as a percentage of 500. And it comes to 8.8%. And that takes us to the end of the question.